In Module 13 and 14, we will move to Chapter 9. This module, we will start introduce what are pointers. And next week, we will start using the pointer to introduce the dynamic memory allocation. So the first thing let's see what are pointers. In this week's agenda, we will talk about the pointers. Basically, the pointer means we will get the address for a variable. So that we will define a pointer variable to refer to the memory location for a specific variable. Of course, the variable can be int data type, double data type, or an object. After you understand the pointer variable, we will start moving to review the array. Because the array actually is referred to the beginning of the memory location for a collection of the data. So that's why pointer with the array name, they are actually work the same. So that's what we will talk about the relationship between array and the pointer, how we're using the array name or a pointer to refer to the element of the array. Then we will talk about the pointer arithmetic. How can we calculate to add or subtract a pointer variable? Then we can move the element one by one. Afterward, in Wednesday's class, we will start talking about initialize or compare two pointers. Of course, we can pass a pointer as a function parameter. So then we will review again when we talk about the searching and the sorting, when we're using the array name to passing the array to the function. Can we replace array name with the pointer? So that's what we'll talk about in Module 13. So the first thing, let's talk about what are pointers. Before we talk about pointers, let's see how to get in the address for a variable. So now you need to remember any variable we define in the program, actually they are stored at a unique address. What does that mean? So for example, we see here we have a num variable we define as an int data type. So we assign the value equal to -99. Right, so this one is how we will write in the program. But from now on, after you understand more about the programming, you should know after we define like this, what happened in the memory. We write this statement in our program, but when we run our program, what happened in the memory? So what happened is here, you know you define an int data type variable called num. So the int data type will be how many bytes? Good, so that's 4 bytes, right? So what happened is when we create a variable, so then for example here we have our variable called num. So then because they are 4 bytes, so what happened in the memory is we allocate 4 byte memory. So that's why I show you here the size for this memory slot is 4 bytes. So then we have the num. So this num variable actually just refers to the beginning of this memory location. Okay, so that's why you see here, I try to make that as beginning. So this num variable refers to the beginning of this memory. So then from here, I using the variable name, so they will go to the memory location here. So then they will read 4 bytes. So from this 4 bytes, I assign the value -99. So of course, these 4 bytes, they are not really right -99. They just convert into the binary number. So 4 bytes is 4 times 8, 32-bit. So in this 32-bit, they will just have the binary number represent for the -99. So that's what happened in the memory. So that's what we will have when we define a variable. So this one is how you write defined in the program. But that's how we happen in the memory location when we run the program. So that's we call the variable. So that's why each variable in program, actually they are stored at a unique address. So this unique address actually is the variable is holding. But when we read the value, we will by default to read 4 bytes and get the value for -99. So that's why when we say get the address for the variable, that will be different. Because usually when we want to access the non-variable, by default, the compiler will read from the value. From now, if I want to know exactly this address, where they are in the memory location, so remember before, we have the address operator ampersand. So if you add your ampersand before the variable, that means you're using the ampersand to get the address for the variable. So that's why here, did you remember before we have this symbol to show you? So when you see out none, they will display -99. But if you see out the ampersand none, they will display the address in the hexadecimal value. So what does that mean? So now you understand what we mean here. You define the variable. Then here ampersand is the memory address, right? So that we see here how our program will really show us. So that's why in example 1, we will see here in the main function, I define a variable I call x. And I assign the value x is 25. So the x data type is int. Right, so that's why remember after we do this, right, that's what happened in the memory address, in the memory location. So that means group everything. Then I copy that. You see here is from the program statement, but here is what happened in the memory location. So we have the x holding 25, that's a 4 byte. So if I want to display value, so usually in line 14, that's what we do, right? We only just display the value for x, right? So by default, compiler see x, they will access the value, they display 25. But if we do the ampersand, so then they will display the address for the x is where in your computer memory. So then, did you remember before we told you we have size of operators? So the size of operator, you can pass in the data type or variable name. So the size of, they will tell you how many bytes in this memory location. So then they will display 4 bytes. So you can see very interesting. You see the 25 you understand, 4 you understand. But when we display the memory address, they will display a sequence, a weird number you don't understand. So this one we will talk about more in the future class. But you should know we have the decimal number is in the human life. We use the 25. That's the decimal number. We use the 10 as a base. For the computer world, we only have 0 and 1. So we call that binary number. So then for the memory address, we're using the hexadecimal number. So the hexadecimal number actually base is 16. So that's why here they show you how the memory address in the computer. So this one is very important. That's my output, right? So then again, I want you to download this program and run on your IDE. Then you will find out you won't have the same memory address as mine. Okay, but you will have the same byte, the same 25 value, because that's the value we interpret. But the memory address actually depends on your computer system, how big your memory is, and what your memory available memory are. So that's why your address will be totally different. So that's why that's run the program on your IDE. So earlier my screenshot just when I ran before from Xcode. So then you can see here the same program we run. then you will see here, you see, yeah, the memory address is totally different. So then you will say, oh, 0x7 is the same. But be careful, 0x, they are not the part of the hexadecimal. They just is computer display the 0x to show you the value later you will display they are the hex number. So that's why 0x just a prefix. So then you can see here in the Cloud9, the memory address for the variable x is at 7FFD4 F2A1 AEC. So you can see this kind of like a big sequence number. So that's in the hexadecimal. So that's your memory address for different variable. It depends on your computer system or when you run the program. Most of the time or any of time when you run again, they may not at the same location. You see here I run again, they are in different memory address because when we rerun the program just restart. So then your computer, the CPU will assign you different memory location. So that's why usually when we have the x, the variable we define, we kind of only care about the value they are holding. But sometimes we need memory address. So that's the memory address. So after you understand how to get the address for a variable, then we talk about the pointer. Because basically the pointer variable just means we will save the memory address in that pointer variable. So we see what is the pointer variable. Pointer variable, usually we just call pointer. So that's a different type of variable. They are still variable, but they are pointer variable because they always hold an address. So that's why whenever we have a variable like x, int, we read by value. But if I define a pointer variable, I read by the address. So a pointer variable actually holds the address for another piece of data. It points to the data. What does that mean? We see here. Pointer variable actually is another way using the memory address, so we can work with that. Because sometimes we don't want to only get the value for that variable. We want to get the memory location. So that's why pointers are more low level than the array and reference variable. So that means you are responsible to finding the address you want to store in the pointer and how you will use that. So that's just the meaning. I think it's easier we just show you the pointer variable. Okay, what mean pointer variable? Here is the pointer variable. So you can see pointer variable, they still have the variable name. They still have the data type int. But the most important thing is after the int, we add an asterisk. So this asterisk is the pointer variable meaning. So actually the data type, we should see that's the whole thing here. This pointer variable actually is referred to an integer value. But here, because after the int, I add asterisk, I know this variable int ptr is a pointer variable. So they read as this variable int ptr pointer variable holding the address of an int variable. So that's why different pointer, they refer to the different data type. The most important thing is this asterisk make this variable become a pointer. So we have this asterisk. So you can have the space between the data type and the variable name. Or sometimes people do like this. The asterisk just next to the data type. Or the pointer just next to the variable name. So either way is fine. So these three ways, they are all the same. So that's how we declare the pointer variable, right? So like earlier we say the pointer variable holding the address. So that's why when we assign the value, we need to assign the address. So that's why here after I define an int pointer called int ptr, if I want to assign the value for this variable, I need to assign the memory address of the other variable. So that's why here you see I have the int variable called num, the value equal to 25. So I define int pointer So then we assign